Hi guys, how are you? Just as usual, give me a moment to check whether I am live or not. Just give me a moment. I cannot see myself live right now. Let me check. I believe. Yes, now I'm live. I can put it a bit down. Yeah, this way it's better. Yep, now it's perfect, guys. So, how are you? Hi, Chetna. Good evening. How are you, beta? That's great. Chetna is now my permanent student. That's nice. It feels good. Okay, this is really good. All right. So, today, as you guys know, that we are going to ace in your term 2 exams with Unacademy Plus, right? And let's begin the class. I will let you know about the offers and stuff like later on. Let's talk about my introduction. You know me already. I am your chemistry educator, Kirti Sharma, and I have completed my graduation from University of Delhi, and I am your chemistry educator. Okay. Oh, you are new. Ah, my kiddo. That's nice. All right. Okay. So, you guys know we started with coordination compounds yesterday, right? We started with coordination compounds. What did we do yesterday? We started with coordination compounds. Yes, Chetna, propagate it within your friends, family, and cousins as well. Okay, so that's coordination compounds, and today is lecture number 2. Today is our lecture number 2. It's raining outside. Yeah, I believe. I guess it's raining outside very heavily. I can like feel it. Like, nice. All right. So before starting, follow Unacademy Champions on Telegram. The link is given to you in the description box so that you will get all the notifications, all the updates of the class. Okay, so that you won't miss any of the class. All right. And since it is Chetna, I am from Delhi, beta. I am from Delhi. Okay. So we are targeting. Even if you write one time, na, I will see your comment. You don't need to like copy paste it. I'll read it. Don't worry. Okay. So yeah, I'm from Delhi and it's freezing here. It's really cold in here. And we are targeting 1,000 subscribers in the beginning. That is 1K subscribers. I believe that this number of subscribers, these like this will be done very soon with your help, and let's see how it will be, when it will be. And you know already that these are the offers which are going on, that if you get the subscription for 12 months you will get additional 3 months free. Okay, so this is something amazing, guys, that you can get. Okay, without delaying, I'll like let you know about the deals and the offers later on. Let's start with our coordination compounds. Okay, so we started from here, right? That's great, Chetna. I was sure about you. Don't worry. Okay, so yesterday I believe we started with coordination compounds, right? So we discussed, the very first thing that we discussed was the applications of coordination compounds. So we discussed that the Prussian blue color, or like it is also called as royal blue color, because it was very, in earlier times, okay, in ancient times it was very difficult to extract that blue color, and only very rich people, only very royal people could afford that color. That is why even now it is still called as your royal blue color, the Prussian blue color. Okay, so apart from it, we saw that many, since your coordination compounds are colored, right, they are found in a variety of colors. That is why they are used extensively in the colorations and in dyeing and in pigment, wherever like color is used in those industries, coordination compounds are used extensively. Okay, so your coordination compounds have specific colors, therefore they find a common place in industries for intense colorations. Phthalocyanide is a class of coordination complexes that the dyes and pigment industries extensively use. Yes, right, Chetna. They use it to impart specific colorations to the fabrics, that is to your cloth. Okay. Next, we have done this already. I am just giving you a quick review that many of the biological compounds in our body, they are also coordination compounds. That's why it is necessary to know how, like, what is their bonding, what are their structures. So that is why it is necessary for us. Okay, so many of the biological compounds like hemoglobin, right, which is found in blood, it is nothing but a complex compound. Even like vitamin B12, which is very essential for our body, it is also a kind of coordination compound. Moreover, chlorophyll, because of which your photosynthesis takes place, right? Chlorophyll is also a your coordination compound. All right, so here we are like we are looking at the applications of the coordination compounds, right? Apart from it, in the extraction of nickel and cobalt, these are metals, right, the D block elements, in their extraction a lot of uh, a lot of coordination compounds are used. And as you can see that we apply the concept of coordination compounds in the extraction of metals from their ores too frequently these days. Extraction of nickel and cobalt involves uses a major use of these compounds, and these metals are extracted by hydrometallurgical processes requiring a lot of complex ions. Okay, Chetna, in January, like we are not planning any menti sessions, bache. If it will happen, then it will be in February most probably, and I will let you know the code at that point of time. Okay, right now I am not planning any menti quiz. Okay, and like after 25th to 30th of January, you won't have your YT classes. Like for these 4 to 5 days, I will be out, and so we will be meeting on 1st of February. Like we have classes, today is 22nd, we have classes on 23rd, 24th, most probably on 25th as well. All right, but after that, no classes for January. Okay, your January classes are only till, no, we have a session on 31st of January. I forgot. We have a session on 31st of January. We don't have class on 26, 27, 28, 29, and 30. Okay. Sorry. All right. Then we started with the introduction. We started with the basics, that is your simple salts. We discussed that your simple salts are just when you simply mix your acid plus your base, it gives you what? It gives you salt plus water, right? It gives you salt plus water. If you take your acid, say as NaCl, sorry, you take your acid as HCl and your base as say NaOH. Okay, so like what salt will be formed? It will be NaCl plus water will be produced. Now when you dissolve this NaCl, when you dissolve this NaCl into water, when you put it into water, then this gets dissociated into its ions, right? NaCl को जब आप when you dissolve in water, it will get dissociated into its constituent ions, that is Na positive aqueous plus Cl negative aqueous, right? That is, these ions are surrounded by water molecules. Okay, that's your simple salts. And what are your addition compounds? When two stable compounds join together to give to give a new compound, to give a more stable compound, that is your addition compound. Then we saw that addition compounds are of two types, that is double salts and complex compounds. In case of double salts, हमने देखा that they do not lose their identity in the solution. That is, like if you have a double salt, say you have potash alum. Okay, the best example, say if you have potash alum, or say you have Mohr's salt, or you have Mohr's salt. Okay, so whenever you dissolve a double salt in water, वो अपने कॉन्स्टिट्यूएंट आयंस में, सभी इंडिविजुअल कॉन्स्टिट्यूएंट आयंस में डिसोसिएट हो जाता है, करेक्ट? सो दैट्स व्हाई वी आर सेइंग दैट इट lose the double salts lose their identity in the solution. They exist as such in crystalline state. When dissolved in water, these dissociate into ions of their individual components. These dissociate into ions of their individual components. So in aqueous solution, they give the test for all their constituent ions. Their individual ions के लिए the test comes out to be positive. ठीक है? And in case of your complex or coordination compounds, what can you say? That when you dissolve them into water, they do not get dissociated into all the individual constituent ions, but what do they give? They give you complex ions. When you dissolve them in water, they give you complex ions. All right, please go to the previous lecture if you do not know what are complex ions. We have done this topic with major with a lot of your examples in the previous session. Okay, so you can watch it and you'll have fun. Okay, you will you'll feel good. Next, here, as I told you that sometimes the teacher give you direct question in the examination, like what is the difference between a double salt and a coordination compound. So here you can see the exact differences which are already given here. Okay, the differences are already given here. That in case of a double salt, these exist only in solid state, means these are stable in solid state, but they get dissociated in the liquid state, right? So these exist only in solid state and dissociate into constituent species in their solution. Second, they lose their identity in the dissolved state. Third, their properties are essentially the same. मतलब जो प्रॉपर्टी डबल सॉल्ट की है, it is related to the individual components. Okay, so their properties are essentially the same as those of constituent species, and in case of a double salt, the metal atom exhibit normal valency. We will discuss like what is the concept of valency in this lecture. Okay, and in case of coordination compounds, you can see here that they retain their identity. That is like simply they don't lose their identity in solid state, as well as in the aqueous form, as well as in the solution state. When they are dissolved in water, even then the coordination compounds don't lose their identity. Okay, secondly, they do not lose their identity in the dissolved state discussed. Their properties are different from those of their constituents. For example, your K4FeCN6, it gets dissociated. When it gets dissociated into water, it gives you complex ions, but it does not show the test for Fe2 positive and Cn negative ions. Which link, beta, Chetna? About which link are you asking for? The one which is given in the description box. That link is for your Telegram group, beta. That's for your Telegram group. Okay. What can you do is simply download Unacademy app. The first step is okay, tell me one thing. Do you have Unacademy app in your phone, or abhi right now you don't have? Just simply download Unacademy app. In live chat. Okay, array, I told you na that I need to create a channel to join the See, just simply send me a message on Telegram. My username is Kirti _Sharma 1223. You can find me on Telegram as well as Unacademy Messenger by this username 1223. Okay, so that you guys can find me, and I'll send you the link of the class, the link of my Telegram group, so that you guys can get connected. All right, so yeah, here you can see when your coordination compounds dissociates, it gives you complex ions, right? Suppose like your complex ion is K4FeCN6. It is K4FeCN6. Okay, this is your coordination compound. So how does it get dissociated? It gives you 4K positive ion. It is your cation. Along with it, it gives you a complex ion. The complex ion is FeCN6 4 negative. This is the complex ion. So see, this is present in the solution, right? This complex ion is present in the solution. So if you take that solution and you test it for the individual ions, that is Fe2 positive and Cn negative, the test comes out to be negative. That is, the test is showing you that there are no Fe2 positive and Cn negative ions present in the solution. That's why I'm telling you they don't lose their identity. The coordination compounds don't lose their identity even in the solution form. Okay, even in the solution state. Okay, so these are the differences between your double salt and coordination compound. Then we discussed Werner's theory. Since Werner uncle was the very first person who tried to explain the bonding of coordination complexes, okay, who was like, he tried to like answer the question like why only certain compounds join together to give a complex compound, why not all the elements. and why are their structures so different? All right, or like these were the type of questions which Werner uncle tried to explain. And this theory is important because he was the very first person like who gave it an attempt to to sort out those questions. All right, next. So, according to Werner's theory, we have already discussed that he said in case of in Werner's theory, in your coordination compound, the metal atom which you have, not just yeah, the metal atom, it exhibits two types of valencies. The first one is primary valency and second one is secondary valency. All right, two types of valencies are there, primary and secondary. Simply बच्चे okay, Chetna, see, it is then up to you, bache, how to manage. Okay, you can, I believe you can watch online as well in your laptop, right, in your laptop and tablet. बाकी rest is up to you, जैसे आपको अच्छा लगे. ठीक है बच्चे? If you are like not able to download it, then it's okay, we can study on YouTube, right? It's okay, no issues. So yeah, your primary valencies correspond to the oxidation number of the metal, okay? And your oxidation, I have told you, right? Suppose if your say the metal is cobalt 2 positive, in that case what will be the oxidation number? It will be simply +2. Whatever charge is present on the ion, it is the coordination number. If I tell you that it is Fe3 positive, in this case what is the oxidation number? It is +3, right? If I tell you that it is Fe2 positive, now what is the oxidation number? It is +2, right? So your primary valencies correspond to the simply oxidation number को ही वर्नर अंकल ने क्या कहा? Primary valency of the metal. And these are your primary valencies are satisfied by anions. Okay, this is an important concept कि उनको न्यूट्रलाइज कौन करेगा? एनायन करेगा. अगर आपका जो कंपाउंड है if it has no charge, so we will say that primary valencies are satisfied by anions. Okay, now these primary valencies are ionizable and these are non-directional. Why? Because if this is a cation, your metal atom is a cation, right? If an ion is present in any direction, so it does not matter like in which direction the anion is present. So that is why it is a it has non-directional properties in case of primary valency. Okay, it is non-directional. Okay, I believe that there is no doubt till now. All right, let's move ahead. Now comes secondary valency. Now your secondary valency corresponds to the coordination number. Now the question, we have already done this, although like what is coordination number? If I tell you that this is Fe, okay, and it is surrounded by 6 cyano groups, 6 cyanide groups बोल लेते हैं अभी के लिए. It is surrounded by 6 cyanide groups. See, the very first thing is they are called as a coordination bond because like when the bonding is happening, so in this case both of the electrons of the bond are donated by cyanide group here, both of the electrons. So that is the only concept of your coordination compound. All right, so your secondary valencies correspond to the coordination number. Now what is coordination number? कि जो आपका central metal atom है, here your central metal atom is Fe, ये कितने group से surrounded है, that is your coordination number. So secondary valencies correspond to coordination number of the metal and are satisfied by ligands. These are non-ionizable and these are directional. Depend करेगा ना कि जो डोनेटिंग स्पीशीज है वो किस डायरेक्शन में प्रेजेंट है. सो इट इज डायरेक्शनल and hence geometry is decided by these valencies. So your coordination compounds will have different geometries, different shapes. Okay, like we have studied in our previous classes, such as square pyramidal, square bipyramidal, tetrahedral, octahedral, right? So your coordination compounds will also have these properties. Do you have you channel in YT send link? Bache, right now I'm only teaching on Unacademy, okay? Where we are studying right now, like it's on Unacademy only. All right. Okay, let's move ahead. So yeah, according to Werner's theory, although Werner uncle tried to explain a lot of stuff regarding the bonding of the coordination compound, and he actually kind of successfully explained as well, but it had some drawbacks, कुछ कमियां थी उनमें. और you can say that the postulates of the Werner's theory were actually based on experimental evidence rather than the theoretical. All right. Now, what were the major drawbacks? कि major limitation क्या थी वर्नर्स थ्योरी की? What were the limitations or drawbacks? मतलब कमियां क्या थी? All right. So पहली कमी was he could not explain why only certain elements form coordination compounds. Why not all the elements form the coordination compound? Okay. So it does not explain why the bonds in coordination compounds have directional properties. ठीक है, उन्होंने ये तो बताया that secondary valency is directional, but why, that he could not explain. Moreover, he could not explain why coordination compounds are color, why they exhibit magnetic and optical properties. All right. So these are the limitations, or you can say these are the drawbacks of the Werner's theory. Okay. In some important terms, we have studied that if this is your coordination compound K4FeCN6, so we know that the one which is present outside the square bracket, it is your counter ion, or it is also called as spectator ion. It is also called as spectator ion. Okay, so it is your counter ion or your spectator ion. Your ligands are, whenever you have multiple ligands, they are present in like normal parentheses, normal brackets, as you can see here. The cyano group is present here. Okay, this is your central metal atom, and this is the coordination number. ठीक है, जो species सेंट्रल मेटल एटम के सराउंड करके रखते हैं उसको, these are called as ligands. You can call them as ligands or ligands. Both the pronunciations are correct. Okay. You can see here complex ion or coordination entity, something which is present inside your square bracket. It is your coordination entity, or it is also called as coordination sphere. It is also called as coordination sphere. Okay. So it is an electrically charged species in which central metal atom or ion is surrounded by number of ions or neutral molecules. Okay. So yeah, your cationic complex entity, when your complex ion has a positive charge, then it is your cationic complex entity. When it has a negative charge, you can see, in that case it is called as anionic complex entity. Okay. Next is central atom or ion. So as I told you that the central atom or ion accepts the electron, right? Both of the electrons are shared by these ligands, and these ligands can be positive Okay, I have already told you how they can be positively charged, right? Because the question that was arising, it was, since ligands are donating electrons, so if a species has a positive charge, that is that the species itself is electron deficient, then how it can donate the electrons to some other species, right? But ligands can be positive. I told you how in the previous session. They can be positive, they can be negative, and they can be neutral as well. ओके, पॉजिटिव के केस में योर एग्जाम्पल्स वर हाइड्रेजीन, मैं बता भी देती हूँ आपको, it was NH2 NH3 positive, right? So the positive charge is present on the right hand side wala nitrogen, and electrons are donated by this nitrogen. So that is how your positively charged ligand uh, is also able to perform as a ligand. योर नेगेटिव तो बहुत सारे हैं, Cl नेगेटिव, Br नेगेटिव, राइट, दीज SO4 2 नेगेटिव, these are the your negative ligands. Neutral में it can be water, and it can be ammonia, it can be CO. These are the neutral ligands. Okay, so yeah, the atom or ion to which a fixed number of ions or groups are bound. Now what are these? They are talking about ligands. कि एक एटम को कितने ligands ने सराउंड किया हुआ है. It is also referred as Lewis acid because the central atom or ion is accepting electrons. So that's why you can also call that it is performing as Lewis acid, right? So you can see, and ligands are in the bottom line, you can see that ligands are the electron donating species bound to central atom in a coordination entity. Cool. Coordination number, the number of ligands which are present, or you can say it is defined as the number of coordinate bonds formed by central metal atom with the ligands. Okay, coordination sphere we have discussed already. The central ion and the ligand attached to it are enclosed in a square bracket, right? We have discussed it in the first place as well. So it is your simply coordination sphere. And what is a coordination polyhedron? I told you that your coordination compound will have specific geometry, it will have specific shape, right? It is directional, it has directional properties. So that's why, like, there will be, the ligands will be arranged in the space in some manner, forming some geometry, forming some shape. So that your spatial arrangement, how your ligands are arranged in space. So your spatial arrangement of the ligands which are directly attached to the central atom or ion is called as coordination polyhedron around the central atom or ion. If your central atom is neutral, then it is called as central atom. If it has a charge, then it is called as an ion. Okay, very simple this is. I believe there is no doubt till now. Okay, let's move ahead. In the end, we did oxidation number. I already made you understand in the previous session what is oxidation number. Then we have homoleptic complexes and heteroleptic complexes. Now what are these homoleptic and heteroleptic complexes? So homoleptic complexes वो होते हैं in which there is only one kind of donor atom, that is only one kind of ligand. I am not telling you only one ligand is present. I am telling you only one type, or you can say one kind of ligand is present. Only one kind of ligand is present. Only one kind of ligand is present. So that is your homoleptic complex. For example, you can see here CONH3 whole 6. Correct? So here you can see uh, all the ligands which are present here, they are all ammonia. सभी के सभी ammonia है, ammonia molecules है. So that is why it is a homoleptic complex. And what will be heteroleptic? You have got it, in which more than one kind of ligand is present. In which more than one type of ligand is present. More than one type of ligand is present. One type of ligand is present. That's your, it is your heteroleptic complex. Cool, guys. I believe you have no doubt till now. All right. Homoleptic and heteroleptic complexes we have done. Let's move ahead. Okay, I have something else for you as well. It has, just give me a moment, I'll add. I will add, no, this is not the right. Okay, give me a moment. Okay, I can't add, or I can. Just give me a moment, I'll add a file. Okay. Yeah. Okay, we have done this. Done. Okay, we were here. Okay, yeah. So we were discussing the ligands now. Now we will discuss about ligands. Okay, what kind of ligands are here? That's what we are going to discuss. Cool. That's what we will be discussing now. So we know that what are ligands? Ligands are simply the electron donating species, right? Ligands are nothing but electron donating species, correct? Now something called as denticity is related to ligands. Something called as denticity. Now what is denticity? Denticity is simply the number of coordination bonds. The number of coordination bonds that a ligand can form. That a ligand can form with the metal. That a ligand can form with your metal, that is M, कुछ उसके ऊपर N positive charge, right? So that is your denticity. Now some ligands are unidentate, or you can also say that they are monodentate. You can say that these are unidentate, or you can say that some ligands are monodentate. Now what is meant by monodentate? Mono means one, uni means also one, correct? So the ligand, suppose this is a ligand, if it can form only on one coordination bond with the metal atom, so its denticity क्या है इस ligand की? In that case the denticity of this ligand is 1. Cool, guys? In that case the denticity of the ligand will be 1. Now what will happen in case of a bidentate? Now this is also called as bidentate. Both means the same, whether it is bidentate or it is didentate. Okay? In case of your bidentate ligand, what do you say? That if this is your metal, okay? So if this is your ligand, then ligand can form 2 coordination bonds. So here the denticity of the ligand, I hope you can see it. Okay, let me draw a bit here so that you guys can see. If I tell you that this is the ligand, okay, so and here is the metal, so we can say that if the ligand can form two coordination bonds with the metal atom, in this case इसकी denticity कितनी होगी? In this case the denticity will be 2. That's what we mean by denticity, कि how many coordination bonds can a ligand form with the central metal atom or ion. It is simply your denticity. Okay, so you can see here what are the what are the examples of monodentate or unidentate ligands. So here you can see the example H2O, NH3. Why? Because you know यहाँ पे oxygen के पास there are lone pairs. Here nitrogen के पास lone pairs. इसके अलावा what can be the example? Your Cl negative, your Br negative. Let's make it a negative. Cl negative, Br negative, F negative, NO2 negative, NO2 negative. Okay, these are the examples of unidentate ligands. That is, they can form only on one coordination bond with the central metal atom or ion. Alright. Next is a bidentate ligand. Now what is the case? I have told you already. They can form two coordination compounds, right? One example is, I can say, carbonato. One example is carbonate ion. Carbonate ion. What is the structure of carbonate ion? It is something like this. CO O O. इस पे भी नेगेटिव चार्ज, इस पे भी नेगेटिव चार्ज. कार्बोनेट आयन इज योर CO3 2 negative na. This is your carbonate ion. So you can see here that if metal is present here, so it can form the bond from this oxygen as well and from here as well. So here your carbonate ion can form two it can form two coordination bonds with the central metal atom or ion. That is why its denticity, that is why you will call its denticity is 2. Alright, that's how you can say. So by didentate ligand, COO negative oxalate ion is also your, it is also your bidentate ligand. Similarly, ethylene diamine, it is also your bidentate ligand. For oxalate ion, its short form is OX. For ethylene diamine, its short form is EN. Okay. I believe there is no doubt till now. Alright guys, let's move ahead. A polydentate ligand which has several donor sites, right? More than one, more than two sites. Okay, so that is your polydentate ligand. EDTA, ethylene diamine tetraacetate. This is your ethylene diamine tetraacetate. This is an example of polydentate ligand. From this ligand, several donations can be accepted. It can form many coordination bonds with the central metal atom or ion. So that is why it is your polydentate ligand. Okay, and ambidentate ligands कौन से होंगे? Those which can, you know, form the coordination compound, form the coordination compound with like more than two sides, right? मतलब they have a tendency to form from more than two sides. For example, if you take the example of NO2 negative, बच्चे it is NO2 और ऊपर negative. It is NO2 negative. Okay. So you know that the structure, if we look at, see, now the bonds can be formed in this way. NO O, if the bond is formed through nitrogen side. If bond is formed through nitrogen side, in that case it is called as nitrito N. In this case it is called as nitrito. It is called as nitrito N. Okay. And if the bond is formed by oxygen side, say it is like this, NO, and here is the metal atom. In this case it is called as nitrito O. It is called as nitrito O. Alright, so this is your NO2 negative. So you can see that it can form a bond from nitrogen side as well as from oxygen side. So similarly, that you have studied your ambidentate nucleophiles in class 11, right? So that's the same meaning. Okay. Cool. Let me know, bache, if there is any doubt till now, and then we will move ahead. So these are your ambidentate ligands. We will start with the nomenclature tomorrow. We will start with nomenclature tomorrow. We will discuss the how to name coordination compounds from tomorrow. Okay. So here you can see whenever you have an anionic ligand. अभी मैं आपको anions के like anionic ligand के नाम बता रही हूँ, so that it will be quite easier for you. First we will tomorrow look at the rules, then for metals we'll do everything. Okay. So in case of your anionic ligand, you simply add an O in the end. Add an O in the end. Add an O in the end. So you can see that bromide is your Br negative. It is called as bromo. Carbonate ion CO3 2 negative. It is called as carbonato. Chloride is called as chloro. Cyanide ion is called as cyano. Fluoride is called as fluoro. Glycinate is called as glycinato. Hydroxide is termed as hydroxo. Oxalate ion is termed as oxalato. Thiocyanate is SCN negative. When the bond is formed through your sulfur side, it is called as your thiocyanato. When the bond is formed through nitrogen side, in that case it is called as isothiocyanato, right? And for neutral molecules, ammonia, NH3 को you will call as amine, water को aqua, carbon monoxide CO simply you will call it as carbonyl group. Which group? Carbonyl group. Ethylene diamine का ethylene diamine ही रहेगा. Okay. So here you can see the naming of the ligands, anionic and neutral. I believe this is okay. You just simply need to add an O in the end, and in case of ammonia it becomes amine. In case of water it becomes aqua. In case of carbon monoxide it becomes carbonyl. Alright. So here you can see the all ligands, unidentate, bidentate, polydentate. All the examples are given here. For unidentate, you have water, ammonia, fluoride, chloride, cyanide, thiocyanate, hydroxide, nitride. These are the examples of unidentate. That is, they can only form one coordination bond with the central metal atom or ion. In case of bidentate ligand, what will happen? They can form two coordination bonds with the central metal atom, and in case of polydentate ligand they can form more than one or two coordination compounds with the coordination bond with the compound. Okay, so we will start with how to name coordination compounds. We will start with how to name coordination compounds. We will start from here tomorrow. Okay, till then you guys study, and let me tell you the offers, the deals which are going on. You can see that if you get the subscription for 12 months, you will get extra 3 months subscription for free. You can see that these are the batches which are going on right now. The Mavericks batch already has started from 17th of January. The next batch will be starting from 1st of February. Okay, it is starting from 1st of February. You can see that it is an all subject batch. Mode of delivery is in English. The another deal is here that if you get the subscription for class 11, you will get class 12 subscription for free. Okay, so these are the schedule, these are the things you can see for class 11, right? And let me tell you about some of the features of Unacademy. Since again you know that there is an outbreak of COVID, so it's better to just learn live from the comfort of your home with the top educators of India. You will get access to all the courses, all the batches which are available in your category, and these are the existing batches. You can see that is it for the day, guys. Okay, you can get connected to me. My username is Kirti underscore Sharma 1223. Kirti underscore Sharma 1223, and my code is Kirti S Live. My code is Kirti S Live. Okay, this is my code, and that is it for the day, guys. See you in the next session. Bye bye.